Sand, and right now I'm going to tell you, I'm going to show you a little bit about decomposing vectors into their x components and their y components. So I'm just going to grab one of these vectors over here. Here we go. And I'm going to go like this. And this vector, I guess I could put it at the origin if I wanted to, at the starting point of the origin. Here's the end point of the vector. Over here, this vector has a magnitude. And we can see that right here is the magnitude of this vector. We're calling it r, apparently. The magnitude of this r is 20.8. So that's how long this vector is. If I make it bigger, then it's going to go to a bigger number. If I make it smaller, it's going to be in a smaller number. So I'm just going to leave it like that, 23. 23 is great. It also gives me over here, this is nice, it gives me theta. Theta is the angle from this horizontal, the x-axis, up to this angle right here. So if I change that, you can see that the angle goes up all the way to 90, boom, and over here down to 0, boom. It also goes in a negative direction too. And I'm guessing these are in degrees. So let's just leave it like this. So now these numbers have changed slightly, but that's just what this angle is right here. Rx and Ry. Now that's weird. R sub x and R sub y. What the heck do those mean? I'm going to make it a little bit more drastic here. I'm going to make this like that. R sub x is 19 and R sub y is 32. Okay, so a vector is like this, is shown like this, and has a direction because it's got an angle right here, and it's also got a magnitude. This is the magnitude and that's the direction. But a vector, this is awesome, I love this. A vector can be broken down into x and y components. So that means that there is a certain amount that this vector goes in the x direction, and there's a certain amount that this vector goes in the y direction. So this vector, you could write this vector as being two smaller vectors added up, and this is the resultant. It really equals the same thing as an x vector plus a y vector. Other people like to say that it's like a shadow being cast. So imagine that you've got like a light source from above over here, and it's being cast downwards, and the shadow that's being cast is a vector that's right here, and there's another light source over on this direction being shown over here, and it casts another shadow over here. So it's like this vector has two parts of it, two parts of this, two realities maybe, I guess, of this vector. You add those two together and you get this final vector. So I'm going to show the component. And over here there's one way to show the component. Here's another way to show the components, and then there's another final way to show the components. So I'm going to start off with this one right here. So these pink vectors right here, the pink ones, they represent, this one right here represents the y component of this red vector, and this pink one over here represents the x component of this red vector. That means that this vector is really made out of this plus this one over here. Now we've been adding vectors tail to tip, so it looks more like this. Okay, so if you add this one plus this one, you'll get the red one as a resultant. So these things really added together, they are the same thing as this. It equals this plus this. So that's all I really mean by the x component, or decomposing this red vector into an x component and a y component. So the y component of this vector is right here, and you can see it's really tall, and it's actually 32 as our units are right here, whatever units that might be, maybe like, I don't know, these can't be meters, but whatever, let's call them centimeters. And over here, that's 19. So this 19 is the x component of this vector, and this 32 is the y component of this vector. And that's all I want you to know, that this vector can be broken into two pieces, right? Like this, these two. You can't just break it into one, but there is an x part of this vector, that's how far it goes in the x direction, and there's a y part, how high it goes in the y direction. I just want to make sure that's clear to you. So let me know if there's any problems with this, and we're going to be using vectors all year, so you got to get used to them. Okay, bye.